Today we're talking about finding square roots. Remember, when we talk about square roots, we're going to be looking for numbers that multiplied by themselves equals the number we're talking about. We just want to make sure we understand how those work. It's kind of another way of looking at our exponents. So what number multiplied by itself equals 25? Well, 5 times 5 is 25. But keep in mind there's also another number, and that number is negative 5. Because negative 5 times negative 5 is also positive 25. So all of our positive numbers have two square roots, both the positive or the negative. So this number is called a square root. It's called a square root because when you multiply by itself, you get the original number. So 5 times 5 is 25. Negative 5 times negative 5 is also 25. So 5 is the square root of 25. Negative 5 is also the square root of 25. So every positive number has both a positive and a negative square root. Okay, as we just showed. 0 only has 1. And it actually is itself, because 0 times 0 is 0. It's the only one because 0 is not positive or negative. When we have things that have numbers that are integers as square roots, we call these a perfect square. So basically, when we have things that have integers as square roots, they are called perfect squares. So here's just kind of a quick list. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. So 0, 1, and 4 would be perfect squares because when I take the square root, I get a nice integer, 0, 1, and 2. Okay. Now keep in mind we could also get negative 1 and negative 2 for those answers as well. So then my next one would be 9, and then 16, and then 25, and then 36. That's just the first beginning part of our perfect squares. We probably really should be pretty good at them all the way up to 12 at least, because they're multiplication tables. That would be the square root of 144, which is 12 and negative 12. But that's just the idea. Basically a perfect square, which is something we're going to use throughout the rest of this year, and it's definitely in Algebra 1, is when you get the square root as a nice integer answer. So next we're going to talk about finding the two square roots of 49. And we just kind of mentioned that 7 times 7 is 49, and negative 7 times negative 7 is 49. The two negatives pair up to make the positive 49. So this next symbol we see is called a radical sign. That's why you see the little dude on the skateboard next to it. This is called a radical sign. It kind of looks like almost like a division sign if you're doing the long division, but it's got that little tail on the front end of it. But this radical sign symbol, a couple of things we want to draw the attention to. So when I see this symbol here, and there's no sign in the front, we talk about using the positive square root only. So anytime you just see that sign all by itself, it's the positive square root. So let's just do the square root of 49. Well, if I don't see anything in front, the answer is actually just 7. It's not plus or minus 7. Whereas up at the top, we basically asked you to say what are the square roots? Well, they're both square roots, but as soon as I put that sign in front of it, it more specifically says just the positive. Now compare that one to this next symbol. When I see this symbol, which is a square root sign with a negative in front, That is still a radical sign, but now we're saying we just want the negative square root. So in this case, if I saw this, I would only consider the answer of negative 7, because that little negative sign in the front. Now I also want you to see this one too, and this is one we will see as well. When I see this symbol, a little plus or minus on the top, whatever the number is on the inside, and we'll just keep using that little plus and minus with the square root of 49, that's basically saying positive and negative 7. Okay, so if we want to know both the positive and the negative, we have two options. We can basically use the verbal language of two square roots, find the square roots, and we can also use the symbol with a little plus and minus in the front. Now a little vocabulary here, the number that is under the radical sign, so remember the radical sign is that, the thing that's underneath, and this the whole entire package is called the radicand. It could be one number, it could be an expression, which we'll see later on, but the entire thing underneath the radical sign is the radicand. So let's just run through a few of these. So number 1, what is the square root of 36? Well, they don't have the little s for square roots, but we know that both of those will satisfy its negative 6 and positive 6. The second one says, what is the negative square root of 64? Well, 8 times 8 is 64. It wants the negative, so it's negative 8. This next one's a little bit trickier. So we're going to talk about a property coming up where we talk about trying to break down square roots. You'll see this more in algebra. But one way to handle this type of a question, there's a property called the quotient property, which basically says I can think of each of the numerator and the denominator separately as the square root of 4 over the square root of 25, and that's the same thing. Now again, the sign in the front is basically saying we only want the positives. So the square root of 4 is 2, and the square root of 25 is 5. Down in the bottom row, you've got to be careful with the decimals. If you're not using the calculator, you're going to be careful here. 81 is a perfect square, so 0.81 is certainly something we can handle. Again, it's only asking for the positive square root, and it is 0.9. Remember, when you multiply two decimals, you're going to add the decimal places together. So 1 decimal place times 1 decimal place gives us the 2 decimal places. So for example, if I just go over here, one of the common mistakes we see on this one is that people want to make this become 0.09 to make the 81, but just notice off to the side that those 2 decimal places get built in, and would make it too far out, when in one case we just need the 1 decimal place. Now the next notation, notice that again we see the plus or minus answer, and we just want to make sure that we can come up with this one, and this basically comes out to plus or minus 3.5. So when we start getting expressions and trying to evaluate the expression, remember there's no variables, so we are looking at a PEMDAS situation. Now in PEMDAS, this little square root thing is really considered an exponent. So we want to keep that in mind. So when I look at my radical signs, PEMDAS, that'll fall under the exponents. We'll show you how to do exponents in Algebra 1 next year, but for now, just think of our square roots and eventually our cube roots as exponents. So when I see this situation for number 1, we're looking at an addition and a multiplication and an exponent. Well, can't really add stuff together with that yet. Very first step I'm going to do is take care of the exponent. So this is going to turn into 5 times 6 plus 7. Then multiplication would come next to get 30 plus 7. That first one evaluated is 37. On to the second one. When I look at this, again the exponent comes first, And as we just saw a moment ago, if I break this one down into the square root of 18 over the square root of 2, neither of those are perfect squares. But what I also want to think about is, can I break this down into something that I can work with? So looking at 18 over 2, that's really the same thing as 9, which is a perfect square. So the very first thing I'm going to do now is do the square root of 9, which is a 3. So 3 1/4 is that expression. Now on the last one, this is the big idea of this entire worksheet. When I have the square root of a number that is then squared, the square root undoes the square, and the square undoes the square root. So we'll just go through the steps to see how this works. So this is basically saying square root of 81 is 9. 9 squared is 81. So remember, square root undoes the square, and the little square undoes square root. They are the inverse of each other. They are inverse operations. So when I see something that is being the square root and then squaring it, it just becomes the radicand, which is underneath. So next we have a real-life application. We have the area of a crop circle. So we want to focus on the crop circle. We know that the area is 45,216. We want to know what is the radius of the crop circle. Well, we know that a radius is halfway across. We're looking at an area. So we want to kind of think about here is, what is the area formula for the circle? So when I look at my area formula for circle, pi r squared, we have the radius, we have the pi, and we have the area. Now we got to figure out what do we actually have and plug in what's there. Well, if I look here again, the area is something we have. So that goes in for the area. They are telling us to use 3.14, so we're going to use that as our pi. This right now is the radius that we're looking for, so we don't have that one. So again, in PEMDAS fashion, we're going to take and try to solve for r. Well, on that side with the r, I see a square, which is an exponent, and multiplication times 3.14. Well, we know that in PEMDAS, multiplication would come first. So I'm going to divide both sides by 3.14. That's going to cancel that out on that side, leaving me with r squared. On the other side, when I do that out, I get 114,400. Now, to undo the square, we take the square root. Remember, we just said it undoes the square. At this point, when I undo the square, I certainly could have two answers for this r from the square roots, but we would never do a radius and negative, so we're only going to do the positive anyhow. But r squared, when I take the square root, is r. When I take the square root of 114,400, I get 120. So the radius is 120, and we're dealing in square feet for the area, so our radius would be in feet. So that's how you deal with finding square roots, and we want to be able to do that because we're going to start seeing a lot more operations with squaring things and then taking square roots to solve things. So just remember, it's not dividing by 2. It is trying to find a factor times itself to get to the radicand, which is the number under the radical sign.